Welcome back to Think Design Work Smart. I'm Alex Bolbok and I'm coming at you from the Mosaic Work Studios, and what I have for you today is an introduction to another architectural style which is called space-based architecture. This is an architectural style that has recently come back in the public. I've seen some articles being published about the use of space-based architecture, and since my feeling is that we are in for a shake-up in how we are doing architecture, part of it because microservices has been used now for a long time, and part of it because of all the forces that are coming into play, AI agents and the need for more APIs and so on. So I think we are gonna need to revisit our architectural paradigms so that we are prepared for what's coming next. And this particular paradigm is one that I find fascinating. So today I will go through a few topics related to space-based architecture, and if you are interested in seeing more, we will have a scheduled architectural kata on this topic, showcasing this particular architectural style in 2 weeks. So yeah, just join us. It will be interesting. So let's start with the first topic, which is what is space-based architecture. Fundamentally, the space-based architecture paradigm is about structuring large applications. So it's not necessarily for small applications. It's about large applications or applications where you expect them to grow. And normally what we would do in that case, we would use something like microservices. In microservices, you'd have a service that has its own database, and those services would communicate to each other in some way. In this case, we are having a similar model, but with a one big difference. There's one big shared database. Only that database, you don't think about it as a data store, but it's an in-memory database. So think about it as distributed RAM, distributed memory. So basically what you have is this data store that lives in the nodes in memory. And this type of data store is called in-memory data grid. And the in-memory data grid manages everything there is to manage about maintaining the data consistency between nodes, moving data between nodes so that access is faster depending on the access patterns, sending events when data changes, and so on. So the simplest way to have a space-based architecture would be if you imagine your whole database being distributed between multiple computers, and then what you have in addition to that is a processing unit. And the processing unit is very similar to a service, right? We can think about it as it being a service that sits on top of this distributed in-memory data store, and that processing unit does certain things. The next thing we need to understand is that processing units never call each other. Instead, what they do, they communicate through the data changes. So if you have a complex data flow, or let's say you have a multi-step data flow, maybe creating a user, right? First you enter a username, then you enter a password, then you ask for more details like a name or address and birth date. This can be done in multiple steps by having, well, you can have a processing unit that stores the username and password. And once this change happens, you get events saying, okay, new user has been created, do whatever you need to do. And other processing units jump and do their own work and save data, and that changes into data, triggers other processing units. So it's kind of like microservices, so services with a shared database, but it's completely virtualized, so you have no idea what's going on. It's transparent, it just exists, and communicating through the data. And because of this type of architecture has a few interesting characteristics. One of them is that you can scale it pretty easily. You can easily add new instances of the same processing unit because you already have the data store in place. So you can multiply the processing units by 10, by 100, by 1,000, by 10,000. It doesn't matter, as long as the data store can do this and your infrastructure can deal with that. So scaling is very easy. Since the data is optimized for the access that you need, you won't have a bottleneck in the database. Well, you will have at some point, but for a long time you won't have bottlenecks. And it's much easier to add new features since these processing units are separate, so they don't interact with each other. So it's easy to add new functionality built on top of the existing data. Now, of course, this means that you also have some downsides, and we will talk about those in a minute. And there's never only advantages. Let's talk next about space-based architecture versus microservices, since microservices is the most common type of architecture that we see now in enterprise environments. So microservices would have these different services that are running on their own thing and with their own databases, and they do eventual consistency. That would be the term, and you have them independently deployable. The most important characteristic of microservices is independent deployability. Now, microservices have a lot of complexity in infrastructure because you need to figure out what are the right microservices, and then make sure that they are logged, they are monitored. You test for reliability, you do some kind of chaos engineering once you get a lot of microservices, and so on. So what happens is that you get a lot more complexity up front when you start implementing microservices. With space-based architecture, what you need to do is to make sure that you have the infrastructure set up for the in-memory data grid. You need to have the infrastructure for deploying these processing units or services, and the rest is pretty much out of the box, right? And because the data is in one big data grid, the challenge lies into figuring out how to structure the data inside that data grid, rather than figuring out from the beginning how to split into smaller units. So I think I see why it is such an interesting approach. By the way, I forgot to tell you one interesting thing. While this has been recently discussed, space-based architecture was originally invented and developed at Microsoft in 1997 1998 and actually used for MSN Live search and so on. So this is, at least Wikipedia says that. So yeah, architecture is not new. Typically we use old models and kind of recycle them. Okay, going back to the comparison. So in terms of infrastructure, space-based architecture looks much simpler. The rules are much cleaner in a way. You have processing units, they don't talk to each other, they communicate through data. It sounds fairly easy to start with and much easier than with microservices. But what you need to keep in mind is that most likely the complexity is the same. Only in microservices, the complexity is in the structure of the services, whereas in space-based architecture, the complexity moves into data. And the complexity is still there, right? This is one of the important things about architecture. We are managing complexity, but you cannot reduce complexity to a lower point than what's needed for the system. And maybe you can remove some of the technical complexity. So in this case, if you don't have microservices, you want it to have maybe Docker, Kubernetes, complex orchestration, logging, monitoring, and so on for each microservice, a request ID for each request, and all that, because you have them built into the in-memory data grid, and you have some additional but smaller monitoring, logging in the processing units. However, the challenge lies in the data, because you cannot escape the limits of architecture. There will still be some limits. And that's why it's so interesting. Let's talk about the next topic, which I found very interesting, which is security in space-based architecture. So how do you do security when everything can access the same data engine, the same data grid? Because this is what space-based architecture is. You put all the data into one big bucket and then processing units start accessing it. So this will be a challenge, and the way this challenge is solved varies. One way is to have role-based access. So just to simplify, imagine each processing unit has one specific role, and that specific role can access specific data from the data grid. Now, of course, this means another layer of complexity. If in microservices we can separate the data because we only have the small database, and so the microservice only has the necessary data in place, so in theory at least it's safer, it's more secure, because if somebody manages to steal, to access a microservice and steal data, it's still a limited data access. Here what you have is, you have this role, you need to define the role very precisely, which means you need to pay a lot of attention on how you are defining the role and what permissions are given and so on. And then that role needs to be used. And but now the challenge is, if a potential attacker gets into, manages to steal access or to gain access using that specific role, there is a certain probability that they will be able to elevate their privileges and access more of the data, Whereas with microservices, even if they elevate their access level and they get, I don't know, instead of a normal read user, they get the admin user, they will just have access to the same data. It's not more than that. So you have this challenge because everything is in one place. And this leads us to an interesting question, which is, should you split maybe the data grid? Should you have multiple data grids? And well, this seems to defeat the purpose, the initial purpose of the architecture. But let me posit one interesting idea. What if instead of having a single data grid, what we would have is we take the domain model, we identify the bounded contexts, and then we split into data grids based on two criteria. One criteria is domain boundaries, and the other criteria is security. So we end up with a larger grid with multiple grids instead of a single data grid, which could prove to be a challenge. But what we have is now a cleaner separation and better security. All in all, it's hard to say. It's hard to say whether this is a good idea because this is more complicated than the initial model. It leads to some additional challenges because you need to manage multiple instances of the data grid. You need to somehow synchronize the data. It helps if you are using the domain boundaries because that data will anyway be somehow denormalized. That's the whole idea with bounded context. You'll have duplicate or data that looks like duplicates, but it's actually the same entity in a different context. So that helps, but you have additional challenges with the data grid. And if you start in this way, then it's a bit more challenging. It's getting closer to microservices. Not as difficult, but closer. However, there's the reverse cost. What if you realize at some point that you need to split the data grid in two? Well, now you have a challenge because let's assume you have now hundreds of processing units and you want to make this split. You need to change at least half of them in order to ensure that they are accessing the new data grid. So it's getting a bit more complicated. Now, I kept this explanation simple. In reality, there's a virtualized middleware happening. So there are probably more things you can do depending on the type of data grid you use and the type of technical solution that you use. But in general, these are conceptual problems. Another thing that you could do for security is to have specific views that filter specific fields, because that's another challenge. So let's say one of your services, of your processing units, only needs access to a person, first name and last name, and that's it. But in your entity, you have the first name, you have the last name, you have the home address, you have the birth date, and so on. If you want to follow the principle of minimal, exposure, minimal data exposure, what you want to have is that processing unit to only see those specific fields. And apparently this is possible through metadata in some of these systems, but it's very complex. You have to maintain it, and you have to maintain it for every processing unit or for every role, and so it can get pretty difficult pretty fast. So another way would be to create views that just expose specific data fields, and that's something that, yeah, you can use, definitely. So these are some of the challenges, but then of course you need to develop those views so, again, and to give them the correct access permissions for the correct roles and so on. So you can already see how this is getting pretty complicated in the data and in the data grid. Now, one thing that I want to mention about the data grid is that it's more like an object-oriented store. So it knows how to store related objects and object graphs. They can do more things. It's always when you talk about data storage in these modern database engines, things get a little bit more complicated because it's not as easy as saying the only model it knows is entity relationship or the relational, or you can usually save JSON, you can save entities with relations, you can have entities with schema, you can have entities without schema, and so on. But one simple way you can think about this is that in your code in the processing unit, you'll basically have objects that have fields, and those objects are the ones that you store. Which also raises another question, which is what do you do when you need to change the schema? And okay, this is outside the security, so let's switch to socio-technical challenges, because, and this will be our last topic. Okay, so what if you change the schema? What if you add a new field? So assume you have a person and you have the first name, the last name, and the home address, but now you want to add a new field, which is the birth year, let's say. Maybe you want to do some kind of validation. Normally what you do is a schema change, but, an upgrade, a migration, a database migration. But remember that these systems are in memory. They are always running. So you kind of have to patch it mid-flight, which means you need to apply different strategies. You could have versioning for each entity. So you have person v1 that has only those fields and person v2 that has the other fields. You could start adding those fields somehow, and so on. So things are getting a little bit more complicated. You cannot just stop it, run a schema update thing, and then it works. You have to manage this in code somehow. Yeah, it's getting a little bit more complicated. Let's talk about other socio-technical challenges. Based on this architecture, you know how Conway's law says that organizations are bound to create designs that map their communication structure. Here I'm afraid that it's possible to get into a kind of a reversed Conway thing where we pick this architecture and this influences our organization. So how would a communication structure look if we start from this type of architecture? Well, it's tempting to have teams that have their processing unit. So maybe you have a team per bounded context or a few teams per bounded context, and they deal with those processing units, and that's fine. But then the question is, who manages the data, and how do you manage data structures in this shared grid when you have conflicts, when you need to negotiate how to share parts of the data. And that's where it's very tempting to go to the old model, which is you have a database administrator, or in this case, probably a database committee of some sort, and you send your proposal and they accept or deny it, to make the changes and so on. And the problem with this is it is slow. It's just adding new challenges, new roadblocks on the development path. So instead, what you'd like to have is something that's more akin to every team is responsible of a processing unit and the corresponding data for that processing unit. And when there are conflicts or when they need to collaborate, the teams need to talk between themselves and figure things out. But you can see how we can easily move into a very centralized style of management, which is not particularly great for fast development. So that's one challenge. And I think this is one of the reasons why you see this type of architecture with teams who are already using microservices. This is very common, apparently, with teams that have some kind of microservices and that are mixing that with this space-based architecture, which allows them to move faster and to avoid having the database as a bottleneck. Because with microservices, you get a kind of latency, right? Particularly when you have a lot of data and you need to move data from one microservice to another, it can get pretty complicated pretty fast, and one such request can increase in time. So when you don't want that, having a space-based architecture is a very logical thing because it automatically moves and it's in memory, so it's very fast. You won't get the database as a bottleneck anymore. But if you have the governance model from the microservices, and teams already know how to discuss between themselves and how to figure out their conflicts, then it's fairly easy to move and to add in a bit of space-based architecture and keep the same model. But if you look at space-based architecture and say, oh, okay, let's just have the data department do the data part and the development department do the processing units, then you are in for a hard time in the way the work will actually work. It's not that great. So other than that, I think the way to do and to get to space-based architecture is very similar to how you would do microservices. I think you need to do domain modeling. I think you need to figure out the bounded contexts. I think you need to figure out the processing units that match the bounded context. Some of the patterns involved with microservices can also work with space-based architecture. For example, backend for frontend. However, it's very likely that your UI needs to embrace the asynchronous nature of space-based architecture, and actually you will see tasks running and progressing, and that's how you will get the progress in your UI. And this is apparently very used for financial systems and for things like online games, um, stuff like that. Netflix is using for part of their infrastructure, so it's a fairly interesting architectural style. All right, so there's a lot more to talk about here, but it's obvious that space-based architecture is an interesting paradigm. It's a paradigm that allows fast development if you're doing it in a good context. It allows you to deal with large data sets. It allows you to scale up and down very quickly, so it's both scalability and elasticity. It's not that great for things like reporting, because if you want reports, those queries will tend to last longer than in other types of system. But the way you can deal with that is building the reports incrementally, because it's an event-based system. So the reporting service could listen to every change and then update the reports as they go. But if you want to do some kind of analytical queries, it's more complicated on this system. It all depends on the data grid, right? It seems easier to start with than microservices, but it seems also more complicated in maintaining the data. With microservices, it's easier to evolve from a monolith to microservice and then restructure between microservices. With space-based architecture, it's harder to split. One processing unit can easily be split into more, but if you want to split the data grid into more, that's when things are starting to get dicey. It can get quite expensive, right? Because there's a completely different programming model. You need somehow to synchronize between the data that is needed between the data grids. So as always in architecture, there are no perfect solutions. There's a different set of trade-offs, and you have to pick the trade-offs that best fit your organization, your systems, your teams, the whole socio-technical system that you have. What do you think about this? Do you find this interesting? If you do, yeah, join us. I will post the link to the architectural kata in the description below, and you can join us for a live work demo of a space-based architecture at a fast space. So within 3 hours, I take a problem that I don't prepare, so it's not scripted. I just take a problem and I go through the steps and end up with an architecture, and we can discuss advantages, disadvantages, trade-offs, and so on. And if you have any more questions or comments about space-based architecture or other architectural styles, let us know in the comments. We love comments, and I love to learn from you. If you are using this architectural style, what have you noticed? What challenges did you have? If you are using microservices, where do you think this style of architecture would help you, and where do you think it won't? Or if you have any other questions about software architecture, ask them in the comments. Thank you kindly for the view, and until next time, remember to think design and work smart. See you next Saturday.